So we have a question here saying balance the redox reaction between dichromate ion and ion to form chromium 3 ion and solid iodine, okay, which occurs in the acidic solution. Okay, so take note of the acidic solution. So we are balancing the redox reaction in acidic solution. Okay, so we'll be adding, remember I said when we are balancing our redox reaction in acidic solution, we will be adding water molecules and hydrogen ions. Okay. Then in basic media, I said you add water molecules and hydroxide ions. Okay, that's for the basic media. Okay, so now here we are balancing this equation in acidic media. Okay, so whenever you are balancing redox reaction, the first thing you do is to come up with a half reaction. Okay, so one is going to be the reduction half reaction, the other one is going to be the oxidation half reaction. Okay, so I'll write the two reactions here, the other side and the other side, so that I separate the two half reactions. Okay, so I have my dichromate there, okay, with the overload charge of -2. You have 7 there. Then in aqueous solution, then it's giving me the chromium 3 ion, okay, with a 3 plus, okay. So you can see this is a reduction reaction, okay. So this is a reduction reaction. Reduction reaction. Okay. Then flow on the other side, you have your iodide ion in aqueous. Then giving us iodine metal. Sorry. Okay. So this is, you can see iodine has been oxidized there. Okay. So this is the oxidation half reaction. Yes, oxidation half reaction. Okay, so we have our two half reactions. Okay, so the next step after you come up with your half reaction is to balance atoms which are not hydrogen and oxygen. So you balance any other atoms apart from hydrogen and oxygen. Okay, so let's balance here, let's balance our chromium, and here let's balance our iodine. Okay, so our chromium there, you can see we have 2 there on the dichromate. Then we have 1 on the products. Okay, so we have to put a 2 there to balance our chromium ions, so that we have the 2 there chromium ion and the 2 chromium ions on the reactants. Okay, so we balance for chromium. For iodine, we had 1 on the reactant, then we are having 2 iodine on the products. Okay, so you have to put a 2 there to balance the iodine atoms. Okay, okay. So after balancing the atoms, the next step you do is to balance now the oxygen and hydrogen atoms. Okay, so balance in other atoms. The next step you do is to balance the hydrogen and oxygen atom. Okay, so I'll start with this one, then I'll come to the other one. Okay, so you can see here we have our our oxygen, which is having 7 on the reactant. Then we don't have any oxygen on the product. Okay, so we have to balance oxygen atoms. Okay, so how do we balance oxygen atom? Is by adding water molecules. Okay, so we are going to add water molecules. So we want 7 oxygen here. Okay, so we are going to add 7 water molecules. Okay, so add 7 water molecules there. Okay, so we'll add 7 water molecules, so that we have 7 oxygen and 7 oxygen on the products and on the reactants. So oxygen is balanced. But what has happened to hydrogen? We have about 14 hydrogen on the reactants, okay? On the products, okay? So we need to balance these 14 hydrogen atoms. So how do we balance it? So we are in acidic media, so we are going to add the hydrogen ions. Okay, so how many hydrogen ions? We need 14 hydrogen ions to balance this our reaction. Okay, so we are going to add 14. Okay, 14 hydrogen ions to balance our our hydrogen ions there. So you can see that all the atoms are balanced now. We have 14 hydrogens on the reactant, 14 hydrogens on the product. We have 2 chromium ions atoms on the reactants, 2 chromium atoms on the products. Okay, so we have 7 oxygen atoms there. We also have 7 oxygen atoms. So we balance this half reaction. We go to the other one. Okay, so we are having we have this is already balanced, so no need of introducing water or hydrogen ion. So this is already balanced. Okay, so the next step after balancing the atoms, the next step is to balance the electrons. Okay, so you find you summate the electrons, okay, on the overall charge on the reactant. Then you also get the overall charge on the what? On the product. Okay, then I should be able to balance the electrons. Okay, so let's do that. Okay, so what's the overall charge on the reactant? Okay, so we have 14. So we have 14 positive there. So we have a 14 charge there from hydrogen, and here the overall is -2. Okay, so we have 14, we have -2. So the overall charge on the reactant is going to be +12. Okay, so that's the overall charge on the reactant. Okay, that's +12. Then on the product, you have a 2 here, which is affecting this. Okay, so these 2, you multiply it with 3 plus there, you're going to have +6. Okay, so that's the electron difference here. Okay, so you will notice that here we have an overall charge of +12, and the reactant is having an overall charge of +6. So meaning the reactant is having electron deficiency of about 6. Okay, so the electron difference between the reactant and the product is 6. Okay, so this side on the reactant where you are lacking electrons, it's more positive. Okay, so where it's more positive, you're supposed to add electrons, and it's more positive with a 6. So I'm going to add 6 electrons on the what? On the reactant here. So I'll add 6 electrons. Okay. Okay, so let me go to the other one. So if I add my 6 electrons, meaning my equation is going to look like this. Okay, so I have 6 electrons. Okay, plus 14 hydrogen there, then plus chromium. Okay, 2 minus. Okay, so this is aqueous. This is also aqueous. Okay, so this is giving me a 2 Cr plus, so this is Cr, this is aqueous, plus my 7H2O. That's the liquid there. Okay, so I've balanced the electrons and the atoms on the other side. Let me balance the electrons and atoms on the other side. So the atoms are already balanced. What of electrons? Okay, so here the overall electrons you have in -2. Then the other side, the overall electrons you have in terms of the charge, the overall charge on the products is 0. Okay, so here we are lacking 2 more electrons. Okay, so there's 2 electron deficiency the other side. So I'm going to add 2 electrons there. Okay, so I've balanced my electrons for both half reactions. Okay, so after this, I have to make sure that my electrons are equal. Okay, so for both half reaction, the electrons are supposed to be equal. Okay, so you can see these electrons are about there are 2 here. Here there are 6. Okay, so I can make these electrons equal by multiplying this reaction with a 3. Okay, so I'll multiply this reaction with a 3. Okay, so what do I have when I multiply this reaction with a 3? So I'm going to get 6 iodine, okay, in aqueous, then giving me our 3 iodine solid, then plus 6 electrons. Okay, so I have 6 electrons. Okay, so the electrons and the electrons are equal. So now let me write my two equations here so that you see what you're supposed to do next. Okay, so I have 6 electrons plus, so I'm writing this one, 14 hydrogens. So in aqueous, in plus my chromium dichromate there, 7 in aqueous. Okay, it's giving me I have 2. Okay, so I have a 2 chromium there in aqueous, then plus 7 water molecules to 4 liquid here. Okay, okay. I bring the other one, which is having 6 iodine. Okay, minus there. So this is aqueous. Okay, so giving me 3 iodine solid, then plus 6 electrons there. Okay, so that's what I'm having. So the next thing you do, you cancel out what is common on the reactant for this reaction, and it's there on the product on the other reaction. Okay, so whatever is in the on the reactant of this reaction, and it's in the product of the other reaction, you cancel them. Okay, so you can see electrons here are on the reactant, even here the electrons here are in the product, so this can cancel. Okay, there's no other common thing you can cancel here. So what you do, you combine the two equations now. Okay, so you combine the two equations. So if I combine my two equations, I have my chromium, my dichromate there, 7 in aqueous. Okay, then plus I've also remained with 14 hydrogen atoms, or hydrogen ions, sorry, atoms. So these are 14 hydrogen ions. Okay, then plus I've remained with there on the other reaction. I've remained with 6 iodine. Okay, 6 iodine ions. Okay, so in aqueous. Okay, so this on the reactant, the other one I've remained with 2 chromium. Okay, A plus. Okay, in aqueous. Then plus I've also remained with 7 water molecules. Wait, okay. Then plus my 3 iodine, okay, as a solid. Okay, so this is how you balance your redox reaction in acidic media. Okay, so for us to confirm if we've done the right thing, the first thing you do, you check the atoms. Are the atoms balanced? If the atoms are balanced, you check the overall charge both on the reactant and on the product. If the overall charges are the same, then you've done the right thing. Okay, so you can see here chromium you have 2, then here chromium you have 2. It's balanced. Okay, oxygen you have 7. You have 7 there, oxygen with balance on the product, balance oxygen. Okay, hydrogen you have 14 hydrogen atoms there. Then we also have 14. 7 times 2, that's 14. Okay, hydrogen is also balanced. Iodine we have so there's a 2 here. Okay, so I was not putting it 2. So there's a 2 there. Here. Okay, so the iodine we have 6. Here we also have 6 on the products. Okay, so iodine is also balanced. Okay, so the atoms, all the atoms are balanced. Okay, so the next thing you do is to check the overall charge. Okay, so we check on the reactant. Okay, so we have 2 minus there. Okay, then we have uh we have positive 14. Okay, positive 14. So I'm having a 2 minus, then positive 14. And then I have, so this times 1, I have minus 6. Okay, so in short, I have 2 minus 14, then minus 6. Okay, so 2 minus, I have minus 14, then minus 6 there. Okay, then what am I getting? Okay, so I have negative 2. Okay, so plus 14. So negative 2 plus 14. Then I have plus negative 6. Okay, so there I'm getting a 6. Okay, so let me do this. So this negative 2 for this, then you have positive 14 for this, and then we have negative 6 for this. Okay, so if I add, the overall I'm getting is 6, positive 6. Okay, then on the other side, I have here I have 2, okay, times 3. I'm also getting positive 6. Okay, so even the overall charges are balanced. These neutral molecules, they have 0 overall charge. Okay, so this is 0, this is 0. So I only have positive 6 on the reactant. Okay, so my entire equation is balanced like that. So that's how you check if you done the right thing or not. Okay.